I had a couple things working. I've done a little bit more. Now I've got it actually generating the particle systems tied into the async thing that was generated. And so now it's my intent to create a method to initialize all this. And I'm not sure I'm going to do it. I've been kind of puzzling it, but I can show you what it currently is doing. So now I can hit play. Maybe. Get rid of this. Alright, there we go. So now I can do something along the lines of tell this to generate, let's say 10,000 points. And I can do that, and I can still interact with the GUI while it's generating and inserting the points into the tree, although it is slowing here. And then when it's done, it will actually generate the particle system from the points. But it's not a like blocking for loop anymore. So that's good. So I'm actually gonna take this down a smidge because of that lag there. But before, when it was generating the data, you couldn't continue to use like navigation and such in here. And now you can. And we can verify that they're very big. And there's quite a lot of them. 10,000 points. And it takes a little bit, but we're not usually going to be generating that many points. It'd be more on the order of like hundreds or thousands rather than tens of thousands. We may generate a few thousand here and there. So now, what does that mean? So now I have the ability to kick this shit off asynchronously, but I need something to orchestrate that to generate the player's home path in the tree at the start of the when everything starts up. So I'm working on this, or I just started working on this. And the idea of this method is to kick off a series of these. Let's do this. What's this kind of thing? Throttled random distribution. we'll set this so that we have a distribution function to work with, and we'll worry about making it support multiple distribution functions after we get this next piece working. So now we've set a random distribution, so we can come up here, we can say so basically what I'm trying to do is put all the information together that I'm going to need. With my universe entity definitions. So that such that I can pass an array of these and have it do my home path generation. So that's what I'm working on. Can I add? Okay, so this is my random distribution. Where's my definition for the interface? I need to see if I can add. Here. Declare. What is it called? Let's see. Throttle random distribution. It has declare event dispatcher. Reading some stuff. Well, for now, we'll just do this. Throttled random distribution. Okay, so we set this to that, and now we have access to... what? All right, good enough. But before we do that, we also... Okay, I know exactly how we can do it. Move all this up. So this is our call to start the event that fields... that generates the point cloud asynchronously. Well, it's throttled. It's not exactly asynchronous, but it gives us the effect of it being asynchronous. So... we need to bind to the event. And think about how we want this to work next. So right now we're passing the root. Now let's go take a look at what we did down here with that. Can I just do this now? I need to make sure. Alright, so before we do that, we want to test to see if that temp variable was actually needed, or if it was just something that I needed during debugging. Can still move around. It's lagging a little bit, so my throttling of the insert needs to change. And then at the end, we get our data. Okay. Looks like that temp variable wasn't needed. Which is great. That means we can delete it. Hello? Can I has game? Alright, I'm gonna play the smoking game where we smoke every time Unreal lags to the point where I can't do anything with it or crashes. Hello, what happened? Do I have control back yet? No, it's fucked. I haven't gotten the error that I was getting before since I swapped over to 5.2, so that's nice. I mean, it's like, obviously it's crashed, but I haven't been getting the error where it won't start back up again. That is fine, let's fucking go. Alright, so proceduralization harness. And instead, we will unbind it after this happens. And then likewise, down here, this needs to be here. And then when this is done, it should unbind itself. No, this is point cloud insert complete. Point cloud insert complete. Not sure if this event should be unbound. I guess it should. I need to be able to control it. Now let's see if what I've done is valid. Make sure everything still works. Generating. Kind of just looking at the axes and looking for lag in rotations of them and such. See, it's lagging now. Okay, does seem to still work. So now I'm thinking about Ugh, hurts my head. Okay, here we go. We set the random distribution. We get the 0 core of the root. We get the node data from the root. We make a random stream with it. We use the random stream for our point cloud. Our spawn count right now is manually triggered, so let's come up here. Node 2 is a target. No, not the struct. The actual object. Node. So this is like kind of tricky because we're trying to design like a loop to iterate over all the universe entities, but in the form of events, and the timing is important. So I do think here we can just do we update the index after we fetch. Oh, I gotta be careful here, actually. Yeah, we need to invoke the event with the entity and the node. Like so. And then we get a single entity. I need to do this. Something like that. Beautiful. Okay. All right, there we go. And now that'll generate the entity data that we need down here. Let's just make a stream. Let's just bind to the event. And call begin generating. Randomization core plugs into the randomization core that was passed in from here. Okay. So this is going to generate our point cloud. And the point cloud's been generated. We come out right down here. And with that, we need this line of actions right here. I think entity has to go down through the whole inheritance frame. Like it needs to be just piped forward the whole way down instead of doing it like this. So we got entity here, but we don't have it here. We can add it. We don't have to use it in any of this. All right, great. I can't actually do that. I have to pipe it through these events too. Alas. I guess I could. Alright, so now that we have that done, we come back out here and we find that we have this universe entity. And so instead of using this in this way, we can break this. And use the bounds from it. Disable the shit off that I don't need. File, save. Ugh. God. Shit's annoying. I wanted to pipe everything through the system. So universe entity pipes an entity, reference node, a reference core. That comes down here. We have reference node, entity, reference core. We're going to eventually invoke begin generating, and this is going to need to take the universe entity and the reference node. And we basically have to pass this through the whole system. Call it blap, 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 blap. Alright, now I get my data piped in here. Okay, so we invoke the generate a point cloud for this entity in this node. As a result, we get the entity and the reference node out of this, and now we're asynchronous correctly, I believe. Like that. Now everybody's happy. Here we go. Do this. We stop it when this has to almost be like a recursive function. So I think rather than just deriving yep, like this. And then we don't have to do all this nonsense. We literally just have to do our Boolean check. To see if we're inside of our array length. Then pipe through our node and core, and then finally increment the index. I think that's how it works, and then put this here, this here. There we go, and there we go. Alright, so now what are we doing here? Every time we pass through this, we have a node and a core and an index, and we snatch the universality of the index we're at. If we don't have any of that, it will break the loop of event generation, and then after we generate our first event, we kick off a index update. Our event comes down here. It has all the stuff we need on it. This is fine. This is fine. So this one takes our data that was just passed to us and starts generating a point cloud. This tells it, this gives it an entity definition and some node to generate those entities in, and some core from that node to generate those entities around. Then comes down, generates a point cloud, then comes down. This is also going to need no. Why can't I change? Oh. We don't want to lose any of our information going through this process because we need it all at various places. Core 2. Okay, now we should get the core back too. Pipe this into our reference core. Bring this down because we were lagging. Let's get rid of all the two strings. So this is basically determining where the center point of the particle system should spawn at. This will come in later. We start talking about origin rebasing and then particle system initialized node core nodes type, like so. This spawns and populates our actual particle system. So now we've gone all the way down through and we've generated one layer, right? The first entity definition. So what I actually want to do is get rid of this here and move it down here. So we will say, okay, yes, we've processed this index, advanced to the next index, and then we will invoke generate initial data again. And to do that, all right, so now we've removed the need to get the entities array. What we need to do now is find a node in core to initiate the next one into. So how can we do that? Well, we have this and this. So how can we use these We can invoke an array item from stream at random from the seed in our node. To select a random entity. Out of the nodes that were generated. And this is just a data model entity, so we still have to do a select to get the actual node. And what we'll do is we will then get from stream, same stream, there we go. Okay, so our initial core becomes this. Our initial node we actually have to look up from the proc tree. We invoke one get our node reference, put it here. All right, so now okay, now populate some initial default values. Um, 1,000 to 6,000. To 8,000. $3,000 to $6,000. We'll do another 10. So we're at 5, 10, 20, 30. Except we won't need to go down that far here, so we'll just okay, now down here, if I did this right, after I've initialized my proc tree and random distribution, so right here, I should be able to simply invoke No, wrong one. That's the wrong one. Generate initial data. And I just thought of something, so comes in here, generate the initial data, node core. I mean, let's try it. We're making some points. Maybe. May have crashed it by setting my breakpoint. Let's restart. I can see why No Man's Sky went with their implementation. It's a lot easier than this. Okay. Well, I mean, I don't want to like it's that what they have is definitely harder than what I'm making here, but like making your underlying framework be like actual accurate representation of where all the stars are in space instead of just star systems that you can warp into and out of is definitely the harder way to do it. And having to hot load all that shit. Okay, so I broke point and it broke. It broke from the broke point. So I'm thinking let's just let it spin for a bit. Have some faith in the system. Oh, no. Fuck. Proc tree 2. Testing. Go. Alright, so we're generating. We're spinning. Yeah, we're still able to at least partially work. Seems like we're still spinning. Oh, I might have crashed it again. It does look like it worked, though. Maybe not. Maybe not crashed. Uh-oh. Unselect, please. The bummer here, I think this weekend I need to just bite the bullet and write this framework in C++. I'm gonna need real asynchronous multi-threading. Well, it did something. Oh, it's making me wonder if I should just stop on the blueprint implementation now that I understand the algorithm and go do it in C++, because like I'm throttling, it's still eating the game thread. It just needs to be on another thread is what I believe to be the bottom line. Crashed again. Yeah. All right. It sort of did some stuff. I'm not convinced it did it correctly, but definitely did some things.